Alright, so in this question, we are considering an aneurysm, which is an abnormal enlargement of a blood vessel. We are considering here an aorta section with a normal cross-sectional area A1, and we are told that it increases to a value of A2 equal 1.7 A1. The speed of the blood through the normal portion of the aorta is given to be 0.4 meters per second, and we are also given the density of blood to be 1060 kilograms per meters cubed. And we are asked to find the amount by which the pressure P2 in the enlarged region exceeds the pressure P1 in the normal region. So we basically want P2 minus P1. We assume that the aorta is horizontal, the person is lying down, so this tells us that the height is the same. And to address this problem, I would use one of these two equations, or maybe both of them, because we can see we have a change in the area, so we can apply the continuity equation to reduce speeds. But we are asked to find P2 minus P1, so we would have to go back to Bernoulli's equation to find the change in the pressure between the two sections. So if we start with the continuity equation, we know that A2 is equal to 1.7 A1, so if we substitute this, it would give us 1.7 A1 times V2. We are given the value of V2, and we know that here A1 would cancel out from the equation. So this gives us that V2 is equal to V1 over 1.7. And we can substitute this in Bernoulli's equation. So Bernoulli's equation would tell us that P2 minus P1, which is what we want, is going to be half rho V2 squared minus half rho V1 squared. Actually, the minus is here and the plus is here. So we know that V2 is equal to V1 over 1.7, so we can write this down. We have the value of V1, we have the value of the density of blood. So all we have to do now is substitute, and then we will end up with the difference in pressures between the enlarged part of the aorta and the normal part of the aorta. So if we substitute this here, we're going to get, first of all, we can take half rho V1 squared as a common, and then we would be left with 1 minus 1 over 1.7 squared. And if we substitute our values, we know that this is 1060 and this is 0.4 squared, and if we substitute these, our final answer for the difference in pressures between the two sections would be 55 pascals.